Hi guys, welcome here. Welcome to this. Uh, Welcome to this Pi. So we want to have the I/O controller, and we want to use our Python to drive this output controller. So there are multiple steps. So one of the steps that we want to follow initially is we bring our uh, model 3V Pi, which is an awesome. It has a chip out here. It has basically I/O ports all there, and we can drive I/O port. I have connected to HDMI port. We are not use a PSPI 2 to a PS2 mouse, and then there is a keyboard out here. Good thing is this particular port of the Linux has all the basically drivers available. So that's why when I first time came, I had an apprehension. Hey, what about the keyboard drivers? Is it there? What about this mouse? Can I do that? And I didn't buy. I pulled out from my old devices and put this PS2 mouse and the keyboard. Awesome. And it has also an HDMI port. Beautiful. Thanks to this Model 3 Pi. It's awesome one. And I immediately wanted to connect it to SSH, but I reminded myself, okay, hey guys, we have been doing this like a Python. If you look at my pie chart, all about it. I have this machine learning, Python's decision trees and everything, right? And this is my pie chart learning, and I want to basically, hey, want to say, hey, very quick. It's very fairly easy for us to basically run. When I run my S3 classifier, for example, out here, the Python code runs seamlessly. I'm using a basically ADABOOST classifier, and it generates and shows her that. Okay, and another, the Python is very rich. I'm a big fan of this one and worked on Python's multiple. So I also have this AWS, which is a big fan of the Python library, Boto, right? And then there's a DJANGO server, beautiful of the Python. I worked on this DJANGO server, and awesome. You can bring the whole REST APIs end to end with course everything, and it beautiful is the model. For example, we had a model for the link and the correlations model that you can create it out here, and then you have the URLs py5 where you can wire your URLs for the REST services. And then you also have settings files, and it says, well, I want to connect to my database PostgreSQL, which I'm running on my Postgres server, and I have all these validators done onto that. This is but so you can basically have the complete server front end back end running all onto that Django I've used on, and on top of that, could Lambda's async of AWS. I worked on Lambda functions in and out for that. For Python also, it is beautiful. It has async S3 libraries and to do that. So you see this is the Python library, and you're using the Boto 3 in S3 URI and running the Lambdas. Let's go on to this. Now the question was, I have this Pi. I want to use an IO controller using the Python, and luckily it has a Python interpreter all built onto that, right? So when I go out here onto this, and thanks to again this, the folks, the great architect developers, they have created this image beautifully. It has not only the Python interpreter all there, which works seamlessly, the IO libraries of the Python low level libraries are all that. So the biggest part of setting is your IOI, right? So I'm going to basically out here. So let's go out here. We have a Raspberry Pi. I connected it out here. You see this one, and let me go out here, this one, and say, hey, what is going on and where I am. I am in my home Pi. I have my folder out here, and I want to basically have the three LEDs to alternate. This is not about the Python. This is showing the power of this one and the portability. The Python code is all accessible to the IO controllers, right? Though I'm a big fan of C, I have worked on Python, on Django's, on Python, different libraries, Flask, Django, machine learning, PyTorch, and the Scikit and all. I wanted to use this Python to drive the IO controllers, and and one of the things I worked long back with the IO controllers and microprocessors. When I found this one, this is exactly. You don't need a microprocessor credit. You have an IO controller, and you have this Pi gauge, and you can do this one. And Python is there. You can do that. Last session that I did was on the C using the thing. This one I had done with the Python quite a while back. I use the Python Blue toolkit and all. Then I thought, wait a minute, as the libraries and API pass, why not put this one so that and the folks who are basically trying to use it, they can basically divide a help. Let's come back again here, and this Python, this library, this one, with GPIO library in Python, I will show you. It's very extensive, very illustrative. So let's go to the hardware setup, and we want to show we have our the model here, and I have the chipset here, and I have this general purpose GPIO pins. There are two things. There's a physical. First thing I found was I'm always found on the physical pins, but the GPIO focuses on the GPIO. GPIO pin and physical pins are two different. Either we follow GPI pin while doing hardware connections, or we follow physical pins. There is a more easy from the coding perspective to use the physical pins, but when you embrace a GPIO library, it's easy for you to make a connections using a GPIO. So I have this little beautiful GPIO board, and I need not have to put the labels. It puts nicely here that I have a pin. All the pins that you're doing, they are GPIO pins. Physical pins are here 1, 2, 3, 4, 5, 6. You go here and you go reverse and connect. And the way I remember is if voltage, ground voltage is out here, and then 3.3 voltage out here, and then 5 volt here. So you see the 5 volt plus and minus out here, and this little square will always, you should remember, has a ground and 3.3 voltage. So this is exactly the image of this one out here, little enlarged. Now let's focus on to this one. I have connected with me jumpers and breadboards, which I worked. Breadboards I have worked long back, and I love it. And this little smaller version of the breadboard which is there, and I have put the resistors, and you can get information online, the resistors and the LED, which is not a big thing, right? So now you have the connections here. There is a wire I'm putting it to connect to the wire. You see this, my wire going negative ground, right, 3 volt, and then I also have a connection out here to this line that is coming out here. You see the ground pin is going out here, and also I have this wire for the power connection or going onto that. I have a pin GPIO pin 17 set up onto that. Okay, if you look at this one, then I have used 3 LEDs here, red, yellow and blue. Okay, they are wired to 17. One is wired to 22, which is the green, and then I have another wire which is coming to this pin number. This is for the potentiometer. This is for this light. It is going for, let's look at this GPIO. It's a 20. This is ground. Sorry, this is a ground. So I have 17, 22. 17, 22 level, and this guy is putting another connection go, and this pin connections, what we are doing, we'll find it right in our code. I have labeled it out, right? Connection to that, and this is like an output. I am putting this guy as an output. I'm saying IO controller, hey, let's forget about this potentiometer. I want to use you as an output guy. These LEDs are my output devices, and I'm going to drive a signal high or low, right? Let's use the Python and the code. Let's run it, and I'll make sure the LEDs are the power off. So we just want to put this power little off so that we can see the LEDs blinking nicely, because some of the LEDs are little, let's go out here. So you see my Pi connected. I have my Python. Okay, so I have the LED Python code. Let's watch this guy. Oh, the red came on. Next, the yellow comes on. The next, green will come on. And the green is a little light. If you look at, if you blinks, it will basically come on. We will again start it because it was for 1 second. We'll start it again. If you put the light, let's put the light off so we can see the green. The green is a little faded on. So let's run it out. Red. Oh, green comes on. It was faded. And yellow comes on. You see? Let's do it again. So we can see all the 3 colors coming up. Red, green, yellow. Beautiful. And it codes out. We have not put a while loop. Let's quickly look at how the code looks out here, right? Code is not, it's more about the Python, the library for the GPIO likes is very illustrative. So I'm using a GPIO library of Python from RPI, RPI.GPIO as a GPO, and also using a sleep function from the time library to import. I am putting a remarks that I'm going to put my red yellow B. By default, I did not put the label for R. So this means my by default is a red LED. It is wired to 17 GPIO port. Then I have a LED, right? It is wired to 22 to this port 22, and the physical pin is 15, right? And then I have a 25 LED powered to 22. Okay, so I have these pins connected out here. Now I'm using the board. So first thing that you have to using the GPIO libraries to tell this board, hey, what is this board? I want to set to the GPIO mode of the web. So I'm saying, hey, set mode to GPIO board. Now my LED number that is giving is 11. All right. So I have this physical pin. So one I mentioned is physical pin, another the GPIO pin, all there, right? So in the library. So we go out here and we make this connection set up to LED. So this is the LED pin. And I'm saying, hey, I want you to be an act as an output. So this is the first line says the red LED, the pin will act as a GPIO out, is an out. Similarly, green GLED to also output, and YLED also. So I have these three pins, all are working as an output, right? Okay, now I'm setting the button. For the button, you see there's a potentiometer mode button here. I'm setting this button, push button as GPIO in and pull GPIO pulled up or down. Okay. So this code is focusing, I'm going to put a little sleep timer for 0.05, and then I'm going to say output to make it high. If you want to make LED high, all you have to say is just make the pin high, right? In the terms of voltage, if you put a high voltage, which is like a 3.3 volts or a 5 volt, depending on your devices, it will make it on and off, right? Low is the ground value, which is typically. So all we are doing is in the pin is the IO controller is driving. When you say GPIO output, it's sending high here, right? And then I sleep for 3 seconds, and then I basically make this LED off, makes it low, all right, and do that. So similarly, I'm doing now for the sleep 0.05 seconds. Now I'm doing for the green LED. So I put for GLED, and then for sleep 3, and then I said GP output GLED and to LO, and then print. Then I go to the yellow Y, sleep 3. So I say GPIO output LED high, and then GPIO to LED high. Now watch, we can again quickly go and see. This is very illustrative. Again, the GPIO library, you just label the pins and use its API. You just do setup. This is very important here because the GPIO library has 2 modes. I want to use a mode as the IO board. After this, any commands that it basically use inside built in like a switch case kind of statements in the RPI library to use at the board. So I'm using it LED for the out. These are output. So these are more 3 output. These 3 pins are acting as an output port. Okay, I'm driving a simple output dot output as a high or dot output as a low and pin number, and it makes the job done, and put the sleep. So we're gonna just do the same thing, the fashion we did out here, and we do this, and this way we are able to see our hardware connections that are coming out. How does it that's gonna look it. So again, so you see the first goes is the red, then goes is the green, 3 seconds, yellow, sorry, 3 seconds, then sleep for 0.5 seconds, and then comes here is we're gonna do again the green goes second after that. We will just put this one, we'll put it so that we can watch the green. The reason is green is the luminosity of the LED is little thing, so in the lights it fades out. So you see the green is showing it beautifully, right? It's all about the luminosity built inside that, and that is that yellow. It goes. Thank you guys. Happy coding. Bye.